from Dyna Forecast who would be taking us through. But before that, I will just quickly have a quick introduction about Dyna Forecast. And while we are going to have the presentation from him, people could use the chat window. We have our team who can look at your questions or queries and post them to Pranesh. Or if you feel that during the course of discussion, you are really wanting to have any quick query to be asked, you can always post it in the chat and we will help you, ask that to the speaker. So just to give an overview of Dyna Forecast technology, right? It provides cutting edge technology to monitor the foundry division functionality primarily, which is considered at the forefront of all the manufacturing sectors, right? Like whether it is automotive, machineries, aerospace, defense, and other core industries. Now, looking at the whole Make in India as well as globally, I mean, India, Southeast Asia, a lot of countries where the manufacturing is really going to be growing at alarming pace. This is very, very pertinent as to what Dyna Forecast team has really set up and has been serving these multiple industries. And most of the casting units in operation today have a conventional methodology, as we all might know. Dyna Forecast provides an industrial IoT, Internet of Things, connected end-to-end platform for foundry from raw material to dispatch. Now, today we have with us Pranesh Muruganandham from Dyna Forecast, sharing their insights on helping the manufacturing sector by providing cyber physical systems in industrial IoT. Now, mapping the data from the different equipment and machines with the in-house developed, edge computing devices, and that's, I think, something which they are really developed with a lot of passion and a lot of experience on the ground. And how can one analyze and monitor the efficiency of man, machine, and material tracking on the shop floor? Now, this might sound very, very normal, right? As to every alternate company might be saying that that's what they intend to do and they do. But here, I would urge you to really have a very good ear, and a quick introduction of the speaker will always help, so that you can know the context as well as have relevant conversations with Mr. Pranesh. He is a founder and CEO of Dyna Forecast Technologies, a company helping the manufacturing sector through various technologies like, as I said, industrial IoT, digital twin, AI and ML, obviously, to get insights and generation. With a decade-long experience in manufacturing sector, R&D and product development, he's extremely passionate and dedicated to digital transformation using Industry 4.0 technologies. Now, at Dyna Forecast, Pranesh has led the creation of various tools and technologies which have really benefited multiple organizations specializing in manufacturing. So having said that, without much ado, I now invite Mr. Pranesh to begin this session and provide valuable insights. Pranesh, the floor is yours.
Yeah, so good noon to all. So first of all, I would like to say thank you to Uday. So you have given the brief about what's Dyna Focus and what we are. And thanks for the incubator hub for organizing the whole event, and then asking the people to attend and then gathering for this webinar. It's really good to meet this much people, and talking about the cutting edge technology, what's going to be in the future. So it would be the really good opportunity for Dyna Forecast to showcase their case studies or capabilities. So yeah, so myself, Pranesh, so I'm the founder of a company, and then I do have other team members who's running behind the wheel, like they are the core players who is bringing the bits and pieces, and then they are bringing the whole solution together for the different industry. So I would like to tell something about Dyna Forecast. We have started with the Industry 4.0. That's a buzzword, but like our the real name that I wanted to use is cyber physical systems. That's what the Industry 4.0 means. So this Industry 4.0 is something called marketing buzzword that every people should understand in their for the knowledge transfer or whatever, how it would be useful for any industries. So myself, I and my partner Puvi Arasan. So we both have worked on this cyber physical system long back in Germany. So we do have some experience whenever German Parliament coined this Industry 4.0 technology in 2014. We were there and then we were working on this technology with a lot of pioneer companies like Airbus, Trump, Bosch. So we do have some experience in developing this technology from the grassroots. So I would like to start with my presentation here. So yeah. So Uday, I just want acknowledgement from you that like you can hear all the
Yes,
yeah,
yes, yes,
yeah,
yeah,
yeah.
yeah.
Thank you, thank you,
All
thank
fine.
you.
Yeah, thanks.
Yeah. Yeah. So as Uday said, like we are the company who are providing the Industry 4.0 solution for all core industries, from foundry to warehouse or machine shops, and then automotive, any process industries, oil and gas. There's a lot of core industries available which is running our economy in a major scale. So we wanted to provide the IoT solution for the core industries, and that is our uh, goal, that is our vision to kick off this company. So we are providing the end-to-end platform for the core industries from their initial level, from the beginning of procuring raw material to dispatch to the customers. So there's a lot of process in between is happening, lot of equipments, lot of assets is there, lot of man and material is available. So how we are going to streamline this, how we are going to use all these resources efficiently, that's what our company is focusing on. So why Dyna focus? Because likewise, like you have seen, a lot of IoT companies are available, a lot of AI companies are available, but only few companies are working on this IoT for core industries. As I say, like for example, Siemens, and then likewise, a lot of other companies, they are working on IoT for core industries. So Dynafocus is one of the company who is providing this IoT, especially to monitor the accountability, traceability, and transparency. Because we do have software like ERPs and MES to monitor the process of the core industries. But all these software tools, these mechanisms are like the bookkeeping softwares that obviously we do have that software because that is going to be the traceability for everything. But when it comes to the data, that like it's more like that it's a post-mortem analysis, because once the process is done, then we are going to feed that data to the software. So it can be manipulated data, or it can be the delayed feeded data, or it might be anything. So the data that we do have in the ERP, that might be right, that might be not fit into the actual process, what is happening on the floor. So what we wanted to is we wanted to fill the gap here. So we wanted to collect the data from different sectors in the core industries, and we are directly integrating the shop floor to the ERP like business intelligence module. So we have developed this software hardware for these IoT systems, because whenever the data collection is happening, so there is a two to three different methodologies there. Either you can collect the data from the ERP device, and then like you can analyze your business model or your business process, or like you can get any other standalone IoT system from any other manufacturers, or you can integrate the device. So we have chosen the device wise data collection uh, for the data tapping. So Dynafocast have won the one of the Innovator Year award back in 2018, when we have developed this whole module, the device module, IoT device, because we wanted to pitch the device in any IoT sector. Either it can be a high-end machine, or it can be just weighing scale. So all these hierarchy of machineries that we can integrate with, and then we can tap the data. So that is the data collection from physical shop floor to dashboard, high-end dashboard.
Excuse me, Pranesh,
Yeah.
are you moving your slides because it is still in the first why Dana forecast slide? Is that what you are showing?
Yeah. This is the slide I'm in now.
Oh, okay,
Yeah.
go ahead. Sorry.
Yeah, I'm
Go ahead.
going to move in. So yeah, we do have our core team with multidisciplinary expertise. So one is handling hardware, software, and is another guy is from communication who is managing domain. So we do have core team a core team of 8 people who is in the different domains. And now our team is like 20 plus people are there, including lot of expertise in IoT engineers on the field engineers, who is the developers on the software side. So we are working on multiple sectors with the multiple applications. So I'll show you all the application wise in the later slide. So we have started with the smart factory solution. So this is our first solution we have pitched 5 years back. This is the real-time monitoring for factories. So how we are going to monitor the factory? So first we have to bring the factory to digitization. So any shop floor can be digitization using our hardware. So what we do is we integrate our hardware with whatever the system can be monitored. System should monitor from the customer end. Either it can be high-end injection molding machine or foundry furnace, CNC machines, or any kind of refineries, warehouse. So any kind of equipment or device can be integrated with our hardware, and then we collect data from the hardware, and we provide the hardware. We provide the data as a useful data. We do the backend computation of the data, and then we provide the data to the any ERP or MES system, whichever customer is following existing mechanism, software mechanism. Otherwise, we are also providing the customized dashboard for customers. So if the client needs any customized dashboards that they wanted to monitor, we are also providing that dashboards. So our core area would be the cyber physical system, which is providing the real-time data to any software mechanism or any kind of real-time dashboard. So from this, you can connect with any cross-platform integration that you have already using in that in your shop floor, like quality software or any kind of accounting software. So we can integrate this hardware to any kind of software, and also to any kind of third-party hardware also that we can integrate with. So mainly we are focusing on reducing the downtime and bottleneck tracking, because the industry doesn't uh, uh, believe in individual bottleneck. If you solve one bottleneck in one process, if you solve that, then the bottleneck move to other one. So this is the continuous improvement process. So first we have to find out the bottleneck, and then we have to sort out, like we have to collect the data of the bottleneck, and then we have to sort that out, and then we have to track the next bottleneck. This is how the whole system works. So for this whole mechanism, industry 4.0, Dyna focus hardware will help you out to solve the issue. So here are some technology that we are using in the industry 4.0 scale, especially for this real-time monitoring. So here we have mentioned this AI and ML prediction from our hardware, that I'll explain you later what are the predictions that we provide to our clients. So here you can see there are different types of machines are available in the shop floor. So we connect our device to the individual machines as a data collection system, and from that we provide the Dyna Edge computing device. This Dyna Edge computing device is the core computation device which collects the raw data to the useful data as per customer expectation, or whatever the business scale data that they wanted to monitor. And from that we provide the data showcase mechanism as Dyna Assist. This is our unique dashboard, customized dashboard for each client that we are providing based on the equipments available in the shop floor and data available in the device. So from that we integrate with the cross platform like SAP or any kind of Salesforce or Dynamic 360, any kind of ERP or MES system that we can integrate with. From this system, any team that they are working on the shop floor, they can able to track the bottleneck, and then they can make the decision on the right time to fix the issue, and then they move on to the next challenge. So they'll work on this continuous improvement. So this is our overall solution architect for uh, any kind of shop floor factory. So we are also working on this digital twin technology. So why we need this digital twin technology for shop floor is sometimes the shop floor does have like the machines which is old, like 20 years old, or the system that doesn't have any kind of control system. But that system might be the bottleneck. That system might be the unique resource available in the process. But how we going to get the data from the machine or equipment or the particular system? So for that, we are using digital twin technology. What we do is we provide the virtual machine for the available device which we can't able to collect the data from the hardware. So we write a virtual machine, and then we integrate that as a computation device. So we provide that virtual machine, and then we collect data, whatever the data that customer is looking for from that conventional machine. So this is going to be the cutting edge technology that like lot of industries are working on different scalable machineries, and then the different manufacturers are providing that machinery. Some machine does have the control system, some machine that doesn't require the control system, but everything is included in the process. So that's why we are implementing this digital twin. This digital twin technology is mainly we are focusing this technology for any kind of process industries, oil and gas, and also for foundry and casting industries. So we are the digital twin providers for Hindalco. So we are working closely with Hindalco for implementing digital twin in their casting units. So yeah, this is one of our case study that we have implemented in casting unit. So our casting product is called DFM 4.0. This is Dyna Foundry Management. So what we do is like we integrate with all the machines available in the casting unit, and then what are the individual data that we can tap from the device. So all the data, all the device is connected wirelessly, because we do have unique hardware, LoRaWAN hardware that is capable to tap the data from 1.2 kilometers effectively. So we can tap the data remotely from any device, from any sensors, and then we integrate the data to the bookkeeping software like ERP or any kind of MES available in the floor. So when it comes to casting unit, we collect the data from raw material consumption. So what are the raw materials that are consuming on every day basis, every shift basis, and what is the quality analysis? What would be the production planning and control? So here the outcome would be very straightforward, that like where we are consuming more resources and where we are using less resources, and then you have to find out who's the right person to operate the right machine to do the right job. So these are the correlations that running behind our computation device. It will provide you the detailed suggestion based on the data that we have collected on the timeline. For example, if we have collected the data for 1 quarter, for the 4 months, then we can provide you the suggestion that like you are consuming more resource, you are consuming more material for the particular part. And then when it comes to next time, you can ask your customers that like this is the buffer that like we have to work with. So it's more like operating cost of the resources, operating cost of the individual item. So when it comes to industry 4.0, it's a straightforward monitoring system that it's going to be monitor the asset tracking in the shop floor or any core industries. But whenever the industry 4.0 solution is going to connect with any business intelligence module or going to connect with any KPI of the industries, then only the real industry 4.0 benefit will happen. So that's what Dyna Forecast is doing with multiple industries. That is our core value. That is our USP when we compare to other IoT operators. So here you can see the video of what are the factors included in this casting units and what are the key data that we are providing in the KPI model. So here you can see the number of pieces and what are the data available in the molding and the real-time melting status. So here you can see all the data available in this. All these are real-time data which comes from different machines and which also comes from different departments of the core industries. So we gather all this data in a single roof software mechanism, and then we'll provide the usable data to the ERP or any kind of system that customer wants to integrate with. So here you can see different kind of machines and mechanism, and we are using different devices, hardware devices, and we are tapping this data in a different level. Sometimes it can be wired or sometimes it can be wireless. It depends on the nature of control systems, nature of the machine. So now Dyna Forecast is transforming the whole solution to the AI. So how we are going to implement AI in IoT. So we have transformed our AI based IoT solution 2 years before. So the thing is like we got into the situation that like, yeah, okay, we do have lot of data available in our bank that like we collected the different data from different device, and we also analyze the man and material in the shop floor and everything. So how we are going to provide these AI based suggestions for different clients? So what we do is we see our machine learning algorithm used to learn the 6 months of data from any manufacturing industries, and then it calculates the data pattern based on the inputs that we are providing to our device. So it will calculate the occurrence of the breakdown time, and then what would be the total downtime of the shop floor, and what are the key factors which is affecting your process all the time. Either it can be man, it can be machine, or it can be material. So these three factors are the major factors. But if you don't implement any IoT device, then it won't be solved. The bottleneck would be in a repetitive manner, and then like we keep on like blaming these three factors, but we don't have any kind of factual data to question them. So that's what our solution is going to give suggestion. It will pinpoint the root cause of the particular bottleneck. So you can see the critical production conditions. So it will list out everyday notification that this is the bottleneck and this is the root cause. This is the bottleneck and this is the root cause with the factual data. So I'll just show you how this AI is bringing effectiveness in shop floor. For example, we have seen that these are the shop floor and these are the machines incurred in the shop floor. And then right now you can see the breakdown prediction of the particular machine and equipment. So our AI system will let you know that this system is going to be shut down in a week or in 10 days because of the frequent occurrence of the particular motor issue or particular pump issue, particular energy issue. So based on the occurrence of the fault, it will provide you the detailed suggestions of the breakdown and everything. And also it will show you the utilization in planning. So you are consuming this particular machine very less. You are consuming like you are not even utilizing the machine, then it will affect your overall performance of the plant. The overall equipment efficiency would be lower when it compared to other machines. and auto suggestions of any particular level. If they are using any particular lubricant, or if they are using any particular energy side factors that they wanted to maintain in a particular level, if it goes below the threshold level, it will show you the immediate alert to maintain the data, to maintain that particular parameter. And it also shows the tool life prediction, because like lot of customers will ask for, I don't know how when my tool will end, because they use that tool as a routine production process, but they don't even know when the tool will get lost, because different persons, different labor will use the different tool in a different manner. So our prediction will tell you like this is the particular time that you have to change the tool, otherwise your system will get collapse. So these are the AI suggestions that we are providing to the multiple shop floors. So here I can show you that different shop floor mechanisms, how we are providing. So for example, the runtime of the particular machine, idle time, cycle time, and what is the target and achieved. So this target and achieved, we can integrate with any ERP that the particular machine has this target and what is the current achieved process in that particular machine. For example, if ERP has a production planning for 150 parts, then like no one knows that what is the actual status of the particular machine. So we are providing all those data in a real time, and then we'll integrate with the ERP. And we also provide this runtime, idle time, and cycle time of the any particular machine. So based on this, we can decide, and then we can make the decision, okay, this much utilization that we are using in a particular machine, and this is going to be the critical resource. So we provide any we can monitor any machine or any equipment whichever is bottleneck in the process. So because a lot industries can't depend on one single machine, it is the group of machine, group of process, it turns into the manufacturing industry and it brings the final product. So these are some of the case studies apart from industries. So how we are providing the AIoT solution for supply chain, because in this case study, the total oil, they are supplying oil to Hero Motorcorp. So the case study is they are using the oil filling for every new vehicles. So they have to fill the particular oil. For example, if we take 2 liters of oil, they have to fill in the new vehicle. And then they do have minimal reservoir in the Hero Motorcorp itself, but they don't know when it will get finished, because they have some buffer stock, but their real-time production also changes every day. So the prediction and then consumption of oil is completely unpredicted, and also they need to send the data to total, and then they have to give the oil, the lubricant oil, to the particular plant. So this is like integrating two different sectors like production and also supply chain. So how we are going to implement IoT in these two different sectors? So we are collecting the real-time production value of how much real-time consumption data, how much vehicles have consumed how much data from our device, and then it will directly go to our edge computing device, which is located in the Hero Motorcorp, and from our Dyna Assist, it will provide the okay, so the oil level is going below, going beyond this threshold level or going above this threshold level. It will give the data to the SAP. Through the SAP, the Hero Motorcorp will send the data to Total Oil. So so it will be easy for them to provide the fleet. So it connects the fleet, it connects the transportation cost, and sometimes the transportation doesn't have to wait till they fill the reservoir. Otherwise, the production will get into stuck without any oil consumption. So to fill this gap, we have implemented this case study in one particular plant. So right now they are working on this pilot. They are collecting the data and then they are working on it. So apart from this, AIoT in FMCG. So any food processing industries or any oil and gas refineries. So mostly we are working on condition-based monitoring, because the condition-based monitoring is like it's a daily production data. We have to monitor every equipment, and then we have to monitor every sensor in the shop floor, or every sensor in the refineries. So we are providing the alert system. Whichever it going above the threshold level, it should be very cautious that we have to monitor. So right now we are monitoring this FMCG in ITC industries. It's in a pilot scale. It's working in a ITC sector for the food processing device. So we have implemented two different sensors to monitor the gas line pipes, and then if it goes above the threshold level, it will give you the real-time alert system. So then you can act accordingly, and then you can make the decisions based on in what conditions it's going above threshold level. So it will give you the detailed description of, okay, this is the cost that like our AI system has predicted, and then you have to fix this bottleneck. So it will give you the real-time graph and everything, and then you can use this data as a factual data to fix the issue. So all these sensors are connected wirelessly, because there's no cabling and then no wired hardware is possible in this kind of refineries, because most of this gas pipeline doesn't have space to go and fix that. So we need real-time data. So we are using LoRaWAN gateway to collect data from different sensors, and it will provide you the real-time data. So this particular solution can be fixed into any oil and gas. Right now, we are going to work with Hindalco for this one oil and gas sector. So we are going to implement the same solution to them. So here you can see the real-time demo of our solution in a condition-based monitoring. So I'll just play the video so you can see what are the different equipments, and then different motors is available, and what would be the real-time data that we are providing. So here you can see, if you select the particular motor, it will show you the data available in that motor. So here you can see, for this is the cooling chamber. So what is the cooling temperature? What is the fan speed, humidity, runtime, breakdown time of the particular machine? You can also find out the OE of the particular machine. So whenever it goes above or below the threshold level, it will give you the real-time alert system for you. So in condition-based monitoring, we are providing the overall water consumption of the plant and overall air consumption of the plant in different levels. So here you can see the sensor gas line device. So if it goes in a red, then you have to consider that as a critical stage, that you have to look at that particular sensor, the particular gas line. What is the reason for that, and then like how we are going to fix that. Or it can be the process related issue that you have to adjust your actuator according to that. So all these are real-time data that like single manpower can handle all those systems. So these are our custom-based IoT solution that we are providing to PNG. We are actually like we commenced this for PNG warehouse. So we have submitted the solution for PNG. So it's like Docker availability for the transportation. So either the Docker is engaged or available. So it will we implemented the sensor here, and then like from the sensor we are going to provide the Docker availability in our IoT system. So the real-time and will show you the particular Docker is available, and then you can place your vehicle there. It's more like the parking assist, I would say, and then it can also be used in a warehouse. So we are also providing custom projects for various industries. We are working with one UK consultancy and US consultancy providing this kind of IoT solutions for major industries. Mainly they are focusing on condition-based monitoring and also on the oil and gas refineries application. So we connect with our hardware. So we communicate with our hardware to your system, and then we calibrate the data, and then we correlate the data and provide AI suggestions. That is our 4C policy that we are providing to any customers. So far we have implemented 100 plus IoT devices, 15 plus projects, and then 7 plus sectors we have explored. 5 plus sectors we do have standard product, and 2 plus sectors we are running in a pilot. If it works well, then we are going to launch our product on that sectors as well. And then we have implemented 5 plus AI implementation in the 15 plus projects, and we do have 10 plus product package. That means like we sometimes like we provide software as a service, and also we do have 7 plus hardwares, which starting from low energy Bluetooth to high range LoRaWAN communications. So these are the hardware range that we do have based on the customer requirement and based on the mission capability and based on the control system capability. So apart from this, like what would be the cross-platform capabilities of Dyna hardware would be like, these are the controls, these are the ERP softwares that we have worked with. So our Dyna Assist solution is compatible with this kind of ERP uh, parties. So we can directly integrate with these ERP people with their support. And when it comes to control system capabilities, we do work with different control systems from Siemens, Hitachi, Spectro, and then SCADA. And also we are working with Fanuc with the license software. The customer has to hold that license for implementing the IoT. So these are the different control systems that we are working with. And some of our IoT clients that we are working regularly with these people to implement IoT in their shop floor, because this Lippert, they are the manufacturers in US. They are also using our IoT system for manufacturing. They are into this RV vehicle manufacturing. So we are providing different various IoT solutions for these peoples. And we are also associated with the Startup India, and then this Co India and DPID is the association that they are recognizing our company as a channel partner for IoT systems. And we are working closely with foundry associations all over India. So they know how this networking for IoT system works with industry related people. So yeah, we are operating in Chennai. Chennai, we do have our head office in Chennai. We are also operating in Coimbatore, but our customer base is all over India. We have implemented our IoT device in Delhi, Uttar Pradesh, and then we are working in Cochin as well. So we do have different clients in different sector, and then our support system will be like, we can support our customers remotely anytime, 24/7. And then if you need the person in a insight, then we'll provide you the individual field engineers who can fix the IoT issues, and then you can provide the IoT consultant in real time based on your requirement. Yeah. So this is the overall pitch of the Dyna forecast. So if you guys have any doubt, then like we are more into the discussion, like we can provide you the, if we can provide the answers if you do have any particular doubt that you do have, or like you wanted to pitch any particular product in your plan, then we are here to help you out. Yeah. Thank you everyone. Yeah.
Okay, thanks, Pranesh. Really, I mean, I appreciate, giving you that whole overview. If you may want to, team, are there any questions? There were a couple of questions which were answered by, already in the chat and Q&A. But however, if you may want to, there was a question around LoRaWAN, which you have already mentioned as to whether the LoRaWAN, which you use, is it from any vendor or what is it? You have tie up with various vendors or how it is?
Yeah, for LoRaWAN, we do have our unique hardware, which we are using the LoRa chip that based on the communication scale, we are providing that hardware to the process industries. We are working with that LoRa chip hardware. We integrate that hardware with our system. So that is how we tap the data from uh, process industries. Yeah.
If you may want to share in terms of how is the ROI typically there, right? What I mean by ROI is that how do you
Yeah.
actually then, integrate various stakeholders,
Yeah.
and also in terms of getting the whole data into the business intelligence module, for instance, right?
Yeah.
Whole of
Yeah.
physical systems data,
Yeah.
that if you can throw a little light on how and when the ROI starts coming for various of your use cases, it might be useful, yeah.
Yeah, so mostly if you wanted to, so the ROI can be calculated in many parameters. Because, for example, if the particular machine is giving you the continuous breakdown and a particular device or particular sensors that you wanted to replace, then if you don't give the timely suggestions for that machine, then the sensor is not available in the market, then you have to keep your machine idle for 3 to 4 days if you don't have that sensor on hand. Because usually these industry related products or industry related spares will you have to wait for minimum of 10 days or 20 days in a timeline. If you don't keep that in a stock, then the machine will go idle for the 10 days. Then you can't use the particular machine. You have to look for other vendors or everything. So from there you can find out the ROI. If machine stops for 1 day, then it will cost you around 25,000 of cost. Then you have to give outsource, then it will cost you around 30,000.
So basically, in terms of there is always a general maintenance at any given plant, right? How the predictive uh, monitoring and insights actually help, if you can share more light on that. While I understand obviously the cost of breakdowns, uh, which is certainly, if it is
Yeah,
avoided, it's
yeah,
a
yeah,
great
yeah,
thing.
yeah. So yeah, when it comes to manufacturing industry, only 50% of the breakdowns will occur from the machines. Other 50% of the breakdown will occur from outside. Either they don't have available material to operate that machine, or either they don't have the energy system or power source issue to operate the machine. So these kind of breakdowns will not into the accountability, will not comes under accountability. It will directly show you that you haven't utilized this machine properly. But what would be the breakdown from man and material side, that we have to get into accountability. So what we do is our system will get the real-time reason from the man, that why this machine is not working, why this machine in ideal state, apart from the breakdowns occur in the sensor side. So what we do is this maintenance, this predictive maintenance or regular maintenance, right now they are using in the bookkeeping sheet, or they are using predictive maintenance sheet, and then they'll take that as an account, and then the separate maintenance team will work on that. But apart from that, if they do have the real-time system, then they can able to work on that particular maintenance. If the particular maintenance is not taken accountability for the 3 months or 4 months, then that would be the bottleneck. Then that's why the machine will get breakdown. Yeah. Sorry, I think it's muted. I think I
Yeah,
couldn't hear.
thanks, thanks,
Yeah,
thanks,
yeah, okay,
thanks,
yeah,
thanks, Pranesh.
yeah,
Appreciate. I
yeah,
mean, Akash has some questions around your hardware costs and recurring costs. Typically, what is your model? Do you have a capex model or opex? Anything if you may want to share, or you want to connect
yeah, yeah,
individually also, Akash.
yeah, yeah,
Solution team can connect. But if you want to throw some light on the hardware and recurring costs,
yeah, yeah, yeah.
yeah.
So our hardware cost is one-time cost. So we are providing hardware based on the machine, and then it's a one-time cost. Our software cost is more like a SaaS-based model, that it's a scalable. It's a one-time platform that you can get it as a enterprise software. But if you wanted to go for scalable, for example, some customers they'll just procure hardware for us for only for 10 machines. But if they wanted to use that for 15 machines in future, we'll just provide the hardware to them, and then they can able to integrate with the software also. So we'll provide the facility to monitor that 5+ hardware in the software. So it's mostly based on the hardware based cost. Apart from that, if they need any particular cloud based monitoring or cloud based controlling or any kind of AI based solution suggestions they need, we will cost according to that customization, and then we will provide the cloud based cost to the customers. That will comes under our AMC.
Okay, so I think it may be good, appreciate if you and your team can reach out to Akash, maybe share your email ID over here, contact numbers you have shared. But if again, in the answer, if you can share so that we can get in touch. Another is, Kumaravel is asking whether
Yeah, I'm
you
seeing that.
said that 6 months of data is needed for your AI/ML system, to learn. Now, what
Yeah,
kind
yeah,
of data would you be required to train your AI/ML model is the question.
yeah,
Is
yeah,
it like based on the use case, or you analyze as to how for a customer what kind of data needs to be gathered? If you may
yeah,
want to
yeah,
throw
yeah,
more
yeah. I
light
get
on
it. I
that.
get it.
Yeah.
Yeah, I get it. So yeah, I'm the only person talking from my side, but I wanted my AI expert Puvi Elson to explain for this particular question. So Puvi, like you wanted to explain this question?
Yeah.
Yeah,
Yeah.
yeah,
Yeah, with the welcome face. So yeah, basically it depends upon the particular problem, because we don't have a generalized model to solve a generalized. We don't have a generalized problem. So it's highly dependent upon the what kind of problem we are approaching. So if I take a manual foundry, so which they getting a raw materials from scrap, also raw material from like a pure metal vendors, and they have to mix it together to create an material at a particular grade. So in this case scenario, we will be sampling the spectro data for every scrap coming in the way. We will be taking not each and every particular part. We will be taking a sampling with a particular mathematical model, and we have to put together the sampling data as a training algorithm. So we will be basically doing a clustering based algorithm, using a clustering based AI algorithm to analyze this particular data. Then we will be using a linear regression models to run what particular quantity of material to be added to keep the number of iteration as minimum as possible. So this is one use case. So now we need a spectro data in a particular predefined sampling rate. This is the particular data needed to train the clustering algorithm, and we feed this data to the regression algorithm to get the desired output. So all this basic data will be running inside a digital twin model to finally give the recommendations. So it's basically depending upon the each and every scenario, because we don't have a common problem for every industry. So we usually getting a real-time data all over from the industry. We will be filtering it, and the sample will be restricting the sample rate so that our algorithm can be run at a faster rate and which don't need a supercomputer. So I hope I have answered the question. If they do have a further follow-up question, I will be happy to answer.
yeah, yeah.
Appreciate.
So added to Puvi's answer, like I wanted to answer something, because like this is the one thing that we have experienced in our hardware, because you based on the occurrence, the breakdown occurrence in the particular machine, we can also map the particular employee who's operating that machine. So the AI will also train the data. So this is the particular person using that machine in a less breakdown scale. The number of occurrence of the particular machine will be lesser if you use the particular manpower. So these are also the straightforward data or straightforward correlation that we can provide from our AI algorithm. Yeah.
Appreciate. Really,
Yeah.
Kuvi and Pranesh, that really helps, because everything about AI is about how it is very pertinent and contextual to what is going to get them the benefit, right? So, and if you have
Exactly.
already that approach, I am sure it helps, and
Yeah.
I'm sure your usable components around AI are something which will help you speed up the process of really getting that machine learning done. So, I
Yeah.
appreciate.
Yeah. 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 So any other questions, like anyone have like any other questions or use cases that you guys wanted to discuss?
Yeah, so generally I would suggest that if you can share as to how your engagement really begins, right? When anyone shows any interest, how would that engagement begin? If you can quickly share as to how do you go about doing any pilot or a concept, proof of concept, to get them that exact insight around how the solution is going to be viable. If
Yeah.
you may want to give a little insight on that.
Yeah, so mostly the customers will come from will approach us with the specific problem or specific bottleneck. So they'll provide us the data that what they wanted to monitor. So they'll provide the list of machines or the list of process which incurred in the challenge, and also they'll provide what would be the outcome. So this is the specific outcome that I wanted to. Because if you wanted to see specific outcome, we have to monitor the multiple data, we have to monitor the multiple process, so then only we can get the particular outcome whichever the customer is looking for. So what we do is we analyze the field, we look forward the machines, either the machine can be integrated with our hardware, whether the control system is viable to integrate with, and then we give the feasibility report that like we can provide this much uh, IoT systems, and then we can also provide the AI suggestion on the particular parameter, and then we'll provide the number of hardwares that is required, and what would be the software cross platform you needed, and what would be the dashboard that you needed. So we'll provide all those BOMs to the customer, and then they'll decide the scale. Either they can be monitored with a single machine, or if they wanted to monitor the whole plant, it is also possible.
Thanks. So, I mean, so what you're saying is that you'll actually just customize and understand, and then be able to get them the right set of approach towards their problem, correct?
Yeah.
Typically, how long you have seen, this takes in the initial stage in terms of getting them that comfort, with the obviously generally we see that this goes through a proof of concept kind of a model generally, right? Saying that a customer pays for setting up a little proof of concept, and then based on that they will realize that okay, there is a benefit of all this.
Yeah. So how we see customers is like, so whatever the outcome that customer wanted would be different. It differs to customers to customer, but when it comes to hardware and machines, it will be same for us. Either it can be high-end machine, or either it can be a normal weighing machine. The hardware side, the platform side would be same, but how we are going to provide the data as a useful data to the clients, that would be differ from customer to customer. Some customers that they'll ask for it should be integrated with the particular cross-platform device like ERP, and then I have to fetch the data. Some customers they'll ask for I need this in an app, and then I wanted to check the real-time alert system. And some customers will ask for like only that team should be responsible for that team is responsible for this, so you guys provide the solution only for that team. It shouldn't be like integrated with anything, it should be a standalone system. So the end data, the user perspective would be different. But when it comes to technology, we see any machines or any device as a cyber physical system, and then we provide hardware to that.
Appreciate. Really great. I mean, that was very insightful in terms of how you really are very focused around giving a point solution which is pertinent to the customer's need. Thanks. Obviously, needless to ask, but I think it would be worthwhile mentioning, you are agnostic in terms of the model of the CNC and the most of the machines. Where I'm coming from, most of them will have a comfort that yes, you give a set of whole machines in the foundry or your manufacturing plant, you have the capability to get data out of whatever required critical machines are there, right?
Yeah, because the one thing the customer is facing the problem is like they procure every CNC machine or they procure every machine from different manufacturers. Not all manufacturer can provide the system with IoT. Even they procure some machines with IoT, they can't able to interface that particular machine to other machines or the whole process. So that's where we comes. So what we do is like we integrate all the machines and then we classify those process and we provide that whole system in a single roof, which
Correct.
is critical, which is non-critical. Yeah.
So I think I'm just trying to get a comfort here for people who are attending, saying that, they be rest assured that your team will be able to get the right set of data from irrespective of what model and machine types you're talking about.
Yeah,
Correct?
yeah.
Thanks, Pranesh. Really appreciate. I think we don't have any Pruth. Any other questions are you seeing anywhere? If you may want to ask those questions, Pruth and Jay.
Okay. Thank you. Okay, yeah. So I don't find any questions, but like we are looking forward to provide if you guys have any other doubts. So we are providing this pitch to Incubate Hub. So like if you have any doubts, you can mail us or you can call us and then like get whatever the details that you wanted in IoT system wise. Yeah.
Sure. Thanks, really. Appreciate Pranesh and team for really having this very insightful and meaningful session. I think we'll surely see as to people who have shown interest, we will see that, we are able to have you connected with them. And obviously you have your email ID also. Please feel free to reach out. Thank you very much and have a good afternoon.
Yeah, thank you. Thank you, Uday. Yeah, thanks for the Incubate Hub team. Yeah. Thank you everyone. Yeah.